Hello algebra students, and welcome back to another video lesson as we continue to focus on factoring. This process of going from standard form into factored form by using factoring, which is what we did a lot last week. And now we're going to take it one step further to talk about how we can use that to solve quadratic equations. Kind of already know how to do it though, I think. And so let's take a look at a few reviews. Number one, try and factor x squared minus 9x plus 8. Pause the video here and see what you get for number one. Okay, remember, we are looking for two numbers that multiply to 8. They're going to multiply to my c value, but at the exact same time, they're going to add up to negative 9. Right? I'm looking for two numbers that multiply to c but add up to 9. Well, a lot of us might try 2 and 4, but if I add them, I get 6. Well, negative 2 and negative 4 would be negative 6. So it's not 2 and 4. What about 1 and 8? Right? Well, 1 and 8, it gives me positive 8, but if I add them, I get a positive 9. We're looking for negative 9, so they both have to be negative. So then I'm going to use these two as part of my factors, x negative 1, or x subtract 1, with x negative 8, or x subtract 8. Right? So we use those two as our factors down here. Okay, and we can use this method because there was an a value of 1, nothing in front of the x squared. Whereas in number 2, there is something in front of the x squared here. And so they're actually asking us to find what is the GCF, the greatest common factor. What do you think is the greatest common factor? Well, remember, greatest common factor is a number and letters that go into all three terms. So what goes into 4, 8, and 12? That would be the number 4. And then we want to check, do they all have an x? Nope, the last one does not. So our GCF is equal to 4. All right, 4. And if we took it out, we'd have x squared minus 2x plus 3 left over. Right? If I divided each piece by 4, that's what we'd have left over. So there's your GCF, all right? Now, we're going to step up some of our problems a little bit from factoring, a little bit of different maybe than what we were doing over here. Okay, let's look at these two. We're back in the packet, page number 2. What's different about these two types of problems? All right, what's different? Well, you notice this one has an a value of 2, which makes it a little bit different, and this one has an a value of 1. However, it's missing like that middle piece, right? So it's missing a middle piece. So there's a couple of things to pay attention to on these. Some important notes. First and foremost, we should always be looking for a GCF. We want to see if there's some number that will go into all of these. Okay? And so if we take a look at letter D, right, I have a GCF in this case of 2. Right? The number 2 can go into all three of those. And what we have to do is in a sense, we take that GCF out. I should do that a little differently. So we take this GCF out here too, and then we have to multiply by something, right, to get back to this original problem, which means I really just divide each piece, each term, by 2. 2x squared divided by 2 is x squared. Negative 20x divided by 2 is negative 10x. And 18 divided by 2 is a positive 9, so we put a plus sign in between. So we can factor by taking out a GCF first. And then what we could do is look at what's inside of this parenthesis here. And are there two numbers that multiply to 9, but at the same time they add up to negative 10? Two numbers that multiply to 9, but add up to negative 10. And indeed, if we used 9 and 1 again, But to get a negative 10, they both would have to be negative, because that's how I get my negative 10. Negative 9 and negative 1. So this parenthesis part can change into x with negative 9, or x minus 9, and x with negative 1, or x minus 1. But don't forget to bring that GCF all the way down and include it, because that's also one of the factors. We have to make sure we put that 2 out front so that this problem could originally look like that. So take out your GCF and then see if you can factor the remaining piece. Now, letter C is slightly different, as we said, because it doesn't have that middle term, which means no B value, no problem. B is equal to 0. So we are looking then for two numbers that multiply to negative 25. But when there's no B, right, this one had that middle term, when there's no B, they add up to 0. Usually it's kind of easy because there's only a couple ways to get 25, and that's 5 with negative 5. 5 times negative 5 is negative 25, and if I add those up, they do add to 0. So I'm going to use these two, x with a positive 5 as one of my factors, and then x with the negative 5 as my second factor. Okay, and again, that's all what we call the factoring process. So sometimes we just have to be careful for what we are looking for. If B is 0, they add up to 0. If A is something other than 1, we might want to look for that GCF. So here's another page, right? What's different? We're hopping over to page 3. And if you look and read these problems carefully, solve x squared minus 11x plus 19 equals negative 5 by factoring. Solve 2r squared blah, 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 by factoring. We are solving. There's a difference between just factor or find the factors and solving. First important note, you will see that equal sign. Okay, we're going to factor first, and then we're going to find the x-intercepts, but this is the most important note on the bottom, right there on the bottom. Make sure the equation equals 0. We can't do anything until the equation equals 0 and it's in standard form. Okay, that should be the first thing. Once that's done, then we look for our GCFs and see if there's a GCF, and then we try to factor. Okay, so let's just go ahead. I'm going to go to the next page, and we're going to focus on this one on the left for now. Right now, it does not equal 0. It equals negative 5. So to turn that into a 0, I have to add 5. But whatever we do on one side, we have to do to the other. 0 equals, okay, it's on the right-hand side, x squared minus 11x plus 24. Plus 24. 19 plus 5. All right, so let's check. Is there a GCF? Anything that goes into all three of those? There's not, right? Not all of them have an x, and this is a 1. So now we're looking, right? Because this is a 1, we're looking for our two factors. Something times something else. And then we'll set them equal to 0. But my two numbers, right? I want them to multiply up to 24, the C value. But at the same time, I want them to add to negative 11. Two numbers that multiply to 24, but add to negative 11. Well, we could try 6 and 4, but that's gonna give me a 10, so that's not really gonna work. 8 and 3, so 8 times 3. That is 11. Oh, that's what we need, but I need a negative 11, so that means both of these would have to be negative. Okay, x with negative 8 and x with negative 3. Okay, now that's that factoring process that we've done a lot of. That's the factoring part. But this problem asked us to solve. When it asks you to solve, you're basically finding the x-intercepts. X-intercepts are the solutions. So we really know how to do this. We take one factor and we solve for it. X minus 8 equals 0. or x could equal 8, because that's one of our x-intercepts. So it's also a solution. And then we do that with the other one. X minus 3 is 0. And we solve that, and we get x equals 3. So those x-intercepts are also the solutions. X equals 8 or x equals 3. And if you're ever in doubt, plug them back into the original problem and check to see if they give you -5. Okay, but we got to make sure the equation equals 0. And then we look for a GCF, and then we factor. Number 2 over here. Okay, does the equation equal 0? It does not, so we've got to add 4 to both sides. 2r squared minus 20r plus 48 equals 0. So what should our next step be? Well, we've got to look for a GCF. And in this case, the GCF is 2. We can take 2 out of all of those. When I divide each piece by 2, so I divide that by 2, I divide that one by 2, and I divide that one by 2. We technically have to divide 0 by 2, but that's still 0. We get r squared minus 10r, right? Negative 20 divided by 2, plus what's 48 divided by 2? That's 24. And as we said, 0 divided by 2 is 0. And then, now that we took out the GCF, we're going to try and factor this one down here. Going to factor where I need 2 numbers that multiply to 24, but they also add up to -10. So we're still dealing with 24, but they multiply up to -10. Well, as we kind of discussed, that's going to be -6 and -4 because they multiply to 24, but if I add them, they do add up to -10, meaning I have r minus 6 and r minus 4 equals to 0. And then don't forget, bring that GCF down here. And then we solve. Now, the GCF does not have a variable. There's no letter here, so we don't really have to solve for that one. We have to solve for this one to show that r could equal 6, and solve for the second one to show that r could equal 4. All right, so r equals 6 or r equals 4. So we are using factoring to help us solve or to find those x-intercepts. So let me just quickly review that, all right? Oops, there we go, solving. Number 1, make sure the equation equals 0 and is in standard form. ax squared plus bx plus c equals 0. We got to make sure it's equal to 0. Number 2, check for a GCF. See if you can find that GCF. If you do, or even if you don't, then factor the problem, right? Multiply to c. They have to multiply to c and add up to b, right? When we factor, they got to multiply up to c and add up to b. And then 4, find the x-intercepts, which are the solutions. Those are your solutions. So if you follow that process and that pattern, you should be successful every time. If you're stuck with factoring and how to figure out what factors and how to find them, please make sure that you reach out because the rest of the chapter is all about factoring. All right, folks, if you have any questions, please make sure that you do indeed reach out. Otherwise, until next time, stay safe.